Okay, so let's look at a complicated circuit problem. And this is one that I'm not going to do in class. It's not on the recitation, it's not on the homework. I just want you to be able to use this as an example as to how we solve these sorts of problems. So first thing, let's take a look at the problem. We're supposed to find the current through and the potential difference across each resistor in this circuit. Okay, now my strategize is I'm going to do this. I'm going to take the circuit and I'm going to figure out the total current. And then I'm going to walk through the circuit and kind of like see what happens at each junction. And what does that mean? Well, we'll talk about that on the succeeding slides. You'll see how it goes. But the first piece is this. I'm going to prepare. And my prepare step is I'm going to take this circuit and I'm going to reduce it. I'm going to turn it into something simpler. And I'm going to do that by reducing pairs of resistors in turn. Now check it out. This 5 ohm resistor and this 5 ohm resistor are in series because any current that goes through one has to go through the other. And that is the only simple combination in the circuit as drawn. Okay, the 10 ohm and the 5 ohm, they are not in parallel because there's another resistor in the middle. But those two 5 ohm resistors are in series, and so I can reduce them to a single resistor. I combine them, and I turn them into a single resistor of resistance 10 ohms. Now, with that, I'm going to redraw the circuit. And if I redraw the circuit, I can redraw it without two resistors, just have a single one. So I got a 5 ohm, got a 10 ohm, and now I have a single 10 ohm resistor here. Oh, so now I can say, check out these two resistors, these two 10 ohms, are in parallel because they have the same potential at each end. The potential difference across them is the same. That's the definition of parallel. So I can reduce those two resistors to a single 5 ohm resistor. Okay, with that, I redraw the circuit yet again, and it's even simpler now. It's now like a power supply, a 5 ohm resistor, and a second 5 ohm resistor. And those two are clearly hooked up in series because any current that goes through one has to go through the second. And so I can take those two resistors and I can reduce them to a single resistor of resistance 10 ohms. Okay? So the circuit as a whole looks like this. If I reduce it to a single voltage source and a single resistance, it's a 10 volt power supply connected to a 10 ohm resistor. And so the current in the circuit is just going to be equal to delta V divided by R. It is going to be 1 amp. So that's my preparation step. I figured out the current in the circuit as a whole. And now I'm ready to solve. And for my solve step, what I'm going to do is I'm going to walk through the circuit. And I'm going to look at the potential at each point and the current at each point. So I'll start with potentials. 0 volts here, that's our convention. 10 volts here because it's gone through the 10 volt power supply. And then the amount of current that's coming out of the power supply or the battery is 1 amp. Okay? 1 amp goes through a 5 ohm resistor. I can compute the potential difference across it. The potential difference across it is just I times R. That's equal to 1 amp times 5 ohms, 5 volts. And so I end up with the potential at this point of 5 volts. Okay? Next up, let's look at this 10 ohm resistor. That 10 ohm resistor has a potential difference across it of 5 volts because it goes from 5 volts here to 0 volts down here, which I forgot to mark, but I totally should. Okay, so we got 5 volts across that resistor. And so the current in this resistor is just equal to delta V over R, 5 volts over 10 ohms, 0.5 amps. That's how much current is going through that resistor. Okay, and if that's true, I got 1 amp coming into that junction, 0.5 amps coming out of it. Clearly there's another half an amp that goes this way. Okay? Well, if I got 0.5 amps going through a 5 ohm resistor, the potential difference across it is just equal to 2.5 volts. So as a consequence, I have to have 2.5 volts right here, okay? And I got 0.5 amps going through this resistor because there's no place else for it to go. And I know the potential difference across it because it's 0 volts at this corner of the circuit. And so now I have the current across and the I have the current through and the voltage across each one of those resistors as labeled on the circuit. And the really awesome thing I can do is this. I can do an assess step. Because check it out. If we look at that last resistor, this one right here, we found that it's got 2.5 volts across it. We also found it's got 0.5 amps through it. And we know that it should be true that the voltage across the resistor should equal the current through it times the resistance. And if I take the current through it, which is 0.5 amps, times the resistance, which is 5 ohms, I end up with 2.5 volts. And that is in fact what we found, and that is an independent check on our work. And whenever we do these circuit problems, there's always an additional calculation you can do at the end to check yourself. And this is very much related to a problem which you're going to do in recitation, and it's related to some of the problems you're going to take a look at on the homework assignment, and it's related to some things that we will do in class. So with that, you are set up and ready to solve some problems.